guys, welcome to today's video. In this video we're going to look at the topic integration by parts, and in this topic I'm going to give you an easy way or an easy method in which you can use to solve integration by parts, and it makes it so easy and simpler for us to understand and for us to put into practice. Now this formula is given as the integral of the first multiply the second, times, is equal to the first times the integral of the second, which is equal to, subtracting, I'm so sorry for the errors, integral all into the derivative of the first multiply the derivative of, the integral of the second. Alright, now we're going to take an example. We can apply this method. But we should note that for us to know which of the functions is going to be the first and going to be the second, we need to look for the simpler function. We need to look for a simpler function that is so easy to differentiate. Alright, now let's look into this example. Alright, now given the integral of x exponential 3x dx. Now let's use this formula. Okay, it says we should write down the integral of the first and the second. So we can now looking at this function x and exponential 3x. These are two functions. Integration by parts simply means the product of two functions, integrating the product of two functions. So this is exactly a product of two functions. So now looking at this function, the easier function to differentiate here is x. So we're going to take x to be the first function and exponential 3x is going to be the second function. Alright, now we are asked to write the integral of the first times the second. So we're going to have the integral of x, which is f(x), times the second, which is exponential 3x dx, is equal to the first function, which is, I said x is going to be our first function, multiply the integral of the second, which is exponential 3x dx, subtracting the integral all into bracket the derivative of the first. Derivative of the first simply means differentiating the first function, and the first function is x. So when we differentiate x, we're going to have 1 times the integral of the second, which is exponential 3x dx, all into the x. Alright, so let's continue. We're going to have this is going to be equal to x. When we integrate this, we're going to have exponential 3x all into 3, subtracting the integral of 1, multiplying. When we integrate this, we're going to have exponential part 3x all into 3 dx. So we're going to have this here, x exponential 3x all into 3, subtracting the integral. 1 multiply exponential 3x, we're going to have exponential 3x all into 3 dx. So we're going to have now x exponential 3x all into 3, subtracting. Now this is going to be, you can write this as 1 all into 3 integral of exponential 3x dx. Alright, now this can be given to us, so this is going to become x exponential 3x all into 3 minus, then when we integrate this, we're going to have exponential 3x all into 9 plus c. So therefore this is our answer. It's so easy and short. So we're going to take another example. Okay, taking another example. Now we're given a function, right? Integral of x squared sine x dx. We're going to still use the same method, which is looking for the simplest function to differentiate, and the simplest function we can integrate, differentiate rather, is x squared. Now the formula, we should always remember the formula. The formula is given as the integral of the first multiplying the second, which is equal to first multiplying the integral of the second, subtracting the integral of the derivative of first, multiplying the integral of the second. Alright, now putting that into, using the formula for this function, we're going to have the integral of x squared sine x dx is equal to, what's the first? The first is x squared, then the second is sine x. So the first we're going to have x squared times the integral of the second, which is sine x dx, subtracting the integral of the derivative of the first. That means when we integrate x squared, which is the first, we're going to have 2x multiplying the integral of the second, which is sine x dx, all into dx. So right now we're going to have x squared. When we integrate this sine x, we're going to have negative cos x. So the integral of 2x multiplying, when we integrate this, we're going to have a negative cos x dx. So negative x squared cos x, subtracting, sorry, this is going to be minus multiplying minus, we're going to have plus the integral of 2x cos x dx. Now at this point we're going to see that this integral has now become a product function. So therefore we're going to apply the root to the second integral, taking care to keep the trigonometry function as a second function. That's so we're going to keep the trigonometry function to be the second function. So therefore we can say integral of x squared sine x dx is equal to x squared cos x. Now applying the root to the second function, we're going to have, what's the first here? Is going to be 2x multiplying the integral of the second, which is cos x dx, subtracting the integral of the derivative of the first, which is 2x, is going to be 2, multiplying the integral of the second, which is cos x dx, all into dx. Alright, you seeing this? Right, let's continue like this. So we're going to have here negative x squared cos x plus 2x. When we integrate cos x, we're going to have sine x, subtracting the integral of 2. When we integrate cos x, we're going to have sine x dx. So this is going to be, right, x squared cos x plus this is going to be 2x sine x. Bring that out 2 into the integral of sine x x. So we're going to have as x squared cos x plus 2x sine x negative 2. When we integrate sine x, we're going to have minus cos x all into the x. Alright, so therefore answer is going to become negative x squared cos x plus 2x sine x. When this multiplies, then it becomes plus 2 cos x. So it's going to go out plus c. Alright, now this is the answer when we differentiate. When we integrate a function, but now please take note that when we differentiate and when we got up to this point, we realize that this is good. This already gave us another product function. And remember, when you're solving integration by pattern, when you're solving, come to an extent that you have a product function, you repeat the rule, or sorry, we apply the rule to that product function until it splits. Alright, now we're going to take another example right now. Alright, now looking at this function, the integral of x exponential x sine x dx. Alright, now the formula is giving us the integral of the first multiplying the second, which is equal to first multiplying the integral of the second, subtracting the integral of the derivative of the first, multiplying the integral of the second. Alright, so putting into action, we're going to have the integral, the first and the second, which is this. The easy one to differentiate here is exponential x. So exponential x is going to become the first function. So we're going to have here the integral of exponential x sine x dx is equal to the first is giving us exponential x, multiplying the second, which is sine x dx, subtracting the integral derivative of the first, which is exponential x. That is, when you differentiate exponential x, we're going to have exponential x multiplying the integral of the second, which is sine x dx all into the x. Right, so we're going to have here exponential x multiplying. When we integrate sine x, we're going to have negative cos x minus the integral of exponential x. When we integrate sine x, we're going to have a negative cos x all into the x. So we're going to have now negative exponential x cos x. When this multiplies, it's going to come plus, so we have plus the integral exponential x cos x dx. Now looking at this function, we're having a second integral here, which is now a product function. So we're going to apply the rule to the second integral. So applying the rule to the second integral, we're going to have, we say therefore, we're going to have the integral of exponential x sine x, right, exponential x sine x dx is equal to negative exponential x cos x plus now the first, which is exponential x, multiplying the second, the integral of the second, which is cos x dx. Alright, subtracting the integral, the derivative of the first, which is exponential x, is going to give us exponential x, multiplying the integral of the second, right, all into the x. Right, so now we're going to have here negative exponential x cos x plus exponential x. When we integrate this, we're going to have sine x, alright, subtracting the integral of this, which is exponential x. When we integrate this, we're going to have sine x, all the x, so we're going to have negative exponential x cos x plus exponential x sine x, sine x minus the integral of exponential x sine x dx. Now, looking at this function where we have another integral, another product function rather, but this, if you take a look at this, right, the second function, which is the second function, this is the same thing with the original function given to us. Alright, take a look at this. There's the original function given to us, and now we are having the same function here. So what we're going to do, we're going to collect like terms, which is bringing the integral to one side and bringing a function without an integral to the other side. Alright, so Okay, we're coming to this way. We're going to have something like this now. Alright, so we're going to have now the integral of exponential x, sine x dx. Now let's rewrite the function, okay? This is exponential x sine, okay, which is equal to negative exponential x cos x plus exponential x sine x, subtracting integral of exponential x sine x dx. Alright, now this is the function. I said the right hand side that is the original function, and we're having the original function on the left hand side, so we're going to bring the both of them together. So we're going to have integral of exponential x sine x dx, and when this crosses and equals, automatically the sign changes, so it becomes plus integral of exponential x sine x dx is equal to now since negative exponential x cos x is at the first, we're going to interchange it so that the negative comes to the middle. So we're going to have something like exponential x sine x comes first since carrying a positive sign, subtracting exponential x cos x. Alright, we just have to interchange it. They're both the same thing. Alright, now when you sum up this and this, or when you add this and this together, we're going to have 2 integral of exponential x sine x dx equal to exponential x sine x subtracting exponential x cos x. Alright, now you can also write this as 2 into the integral of exponential x sine x dx is equal to something is common between the both of them, which is exponential x all into sine x negative minus cos x. Alright, so now we're going to divide both sides, divide all through by 2, so that we're going to, so that for us to eliminate this 2 here, so we say dividing both sides by 2, we're going to have now the integral of exponential x sine x dx is equal to exponential x all into sine x negative cos x all into 2. So therefore we're going to have the integral of exponential x sine x dx equal to 1 over 2 is the same thing, exponential x all into sine x minus cos x plus c. Alright, now this is the answer when we integrate this function. It's kind of long, but it's easy when you follow the steps and you apply all the rules when necessary. If this video is really helpful, please do not forget to smash the like button and turn on the notification bell so you're going to get a notification whenever I post a new video. And please do not forget to subscribe to the channel. Alright, and please, if you have a question, please do not forget to put it down in the comment section below, so I'll be able to go through it and answer the question. If you have any topic in which you want me to go into, please do put it down in the comment section. See you guys in our next video.